Right, so welcome to question 4 of the DB mock exams 2020 junior cert. The elevation and end view of a portion of the slide tunnel are shown. The slide tunnel consists of a truncated cone A and a truncated cylinder B as shown. A 3D graphic of the completed slide tunnel is also shown. Draw the given elevation and end view. So look, it's drawn the end view here, is going to be a bit hard for students, but however, it's the elliptical detail is going to be the most difficult for them. Right, so I'm going to draw our square, size of 80 by 80. I'm going to get the center point and I'm going to draw that circle, diameter 70, so radius 35. So I'll do that now. So there's a portion of the end view done, and I can start here with the elevation. Okay, height is 80, or length rather, 80, 10, 20, I'm bringing over the vertices of the circle. Probably a tiny bit off there with that, however. The angle of the cone is 30 degrees until it hits the center line. Oh, sorry, no, it's not. My apologies. I'll rub that out. So, my apologies. The apex is 80 millimeters from the base. The apex is 80 millimeters from the base. So there's the apex of the cone. Okay, and the cut angle goes from the 20mm line intersecting it here. There we go, that's for cone A. And then it says the length of the cylinder here is 54, or one of the dimensions. So I'm going to mark 54 using my compass. I'm going to swing an arc 54 in length. So I'll set my compass there to 54, and I'm going to swing that there. And where it touches this line here, that's the point on the cone, or the cylinder rather. That's one of the extreme generators. So the second one is parallel to that. That goes from here, and then we can connect them together. Now the center of it is going to be found if we bisect this line here. So set our compass to more than halfway and bisect the line. This is going to give us our center line of the cylinder. So there we go. Now to draw the plan view of this, right? So this distance is the equivalent of the distance here. So I'm going to take my compass here, set it to that distance, and swing it both sides and here. And then I can heavy some lines in. There we go. Now, this part here is going to be difficult, right? To do this, we're going to have to divide the cone up into 60-30 in the plan view, or in the end view of it. So I'm going to divide it up into the circle up into 60-30. So I'll pause and do it. Now I have that done. Alright, so what I need to do next is get these numbers over to here. So what I'm showing you is how to draw in the elliptical shape here. It's quite hard for a junior cycle student. It's probably a bit too much. Okay, so I'm going to bring that over to the elevation. Now I need to bring them all to the base of the cone. Right, so they join to the apex here in this view in the end elevation, so they're going to join to the apex in elevation. So I'm going to take all these points here and join them to the apex. So I've joined them all to the apex, these elements, and where these elements pierce the edge of the cut surface, they're points on our ellipse in plan. So that's, I'm going to call this A, B/C, D/E, F/G, H/I, J/K, and then L. So I'll do the two easiest ones, A and L. So A is on the line apex to 3. Okay, so I'm going to bring L back to there. Okay, same, A is on the line apex, the apex to 9. So that's point A. B lies on line A to the apex. So that's where B is. And here's C. Okay, D is on the line 7 to the apex, so it's here on 7 to the apex, and then E is on 11. Alright, F and G are a little harder to get, but horizontal sections, okay, so sections parallel to the base of a right base cone produce circles. So I'm going to measure half of it there and swing a circle, essentially, is what I'm doing to get points F and G. So there are points F and G, then H and I. So H goes to 5, I is going to number 1, and then J and K. K. Right, now I shall pause and sketch them in. Now just 1 second there. Now I don't know why I was telling you earlier that this was what you call it, the width of the cylinder in end view. That's not it at all. I have to go, not sure what possessed me to tell you that. I have to measure perpendicular to the axis. So I take that distance and step it left and right. That's the distance there. Okay, and then I have to freehand sketch these points in. Okay, so I'll just do them lightly and I'll heavy them in later, so it'll be a neater version of the curve. Okay, so I'm just going over them lightly. Okay, I'm not going over it very neatly at the moment. I'll do that in a short while. Right, next thing we have to do is draw the given development of the conical surface A. Right, so every line on a development is a true length. So I'm going to take my compass here, set it to the length of the extreme generator of the cone, and swing it out here to the right. Okay, now you can do that anywhere. So this is my apex now. I want to start it on the lowest point here. Out is the outside, so I'm going to leave 9 as the outside. Now I'm going to set my compass to the distance between 9 and 8. I'm going to step 1, 2, 3, 12 times, so I'm going to pause and do that. So mark them in, and then you're going to lightly join each number back to the apex. It's very important that 9 and 9 are the start points, because that's going to be where the ends of the developments are going to be. Okay, so I'll pause and do that. That done. Now to develop these, right, this is going to be hard to figure out for you, but you got to bring the letters onto an extreme generator of the cone, one of the edges of the cone, because lines there are true lengths, right? So I'm going to start with point. You can see the way I brought them all up to here. So I'm going to start with A. So I'm going to put my compass on the apex, bring my nib to the line there for A, and that's the true length. I'm going to mark here on 9 and 9, because that's where A is on 9. I don't know what I was doing 3 there for. Sorry, I don't know what I was doing. Oh no, never mind. Yeah, that's where it's meant to be, 9. Okay. Now, B then. So I'm going to put a B and C. I'm going to put my compass here, where B and C is being moved to. Going to lift, and it goes on 8 and 10. And then D and E are on 7 and 11. So 7 and 11. Okay, F and G. So I've done D and E. F and G are on line 6 and 0. So look, set my compass to F and G brought straight up, and then I'm going to move them to their relevant numbers, 6 and 0. And then I accidentally put this one here for 11 on the wrong spot, so just correct that. Then next I have is H and I. So there we go, H and I. And H and I are on numbers 1 and 5. So they're at 5 and 1. Then J and K are on 4 and 2. So set it to the true length, 4 and 2. And then the apex, or the L there for the cone, is on number 3. Okay, now I shall just heavy these two edges here for now, and I'll heavy in the development later. I'll sketch in this curve here later, because I want to do the next part first. So we have to develop the cylinder. We have to develop the cylinder first. So the cylinder is going to be unwrapped perpendicular to its axis. So I'm going to line my set square up to its axis, and I'm going to extend out the points here and here. Okay, and then all the letters here have to be extended out as well. So of all those letters extended out, and what else do I need to do next? Right, so now I need to bring the tops of these letters onto this face of the cylinder. Okay, now we have that done. Now, what we need to do is find the cylinder as a circle. where we can get the circumference between them. So just to avoid student confusion, I just drew the cylinder out. I just moved it down here, so it was easier for it'd be easier for students to do it in a space where there's not too many lines. So I'm going to project each of the corners perpendicular to its axis. So it's going to be unwrapped along here. So I can extend on those lines. Okay, and I'll need to see the true an edge view of the surfaces of the cylinder. So basically I need a view where it appears as a circle to do this development. So I can construct a line out there, bisect the line to get its distance. Oh. There you go. Okay, now I need to divide that circle up into 60/30, so I'm just going to do something very quickly that allows me to divide it up into 60/30. You can use your set square if you wish so. So I'll pause and just divide it up into 60/30 and I'll label the points. So there we go. Right, now we're going to bring these points onto the cylinder, top and bottom. So you can see the way I'm projecting them onto it now. So I'm going to continue at that. So I'll just pause and do that. I've labeled all those points. Now what I need to do is take the distance between two of the numbers on the 60/30 here. I can start wherever I want, and I'm going to step it out. Okay, the number segments here. So it starts at 6 because this is the shorter end. So I'm going to step the total number of distances here. You'll see it once done. Once I have the numbers marked in, I'm then going to draw parallel to the center line of the cylinder. Okay, and I'm going to project or draw all these lines in from each of the numbers. Okay, so all those lines there. You can see I have that done. Now I'm going to bring the lines, the numbers to their relevant numbers. So I'm going to bring 1 and 11 to 1 and 11. So 1 and 11, 0 there to 0. 10 and 2 to 10 and 2. Okay, 9 and 3 to 9 and 3. 4 and 8 to their relevant numbers. 5 and 7. And then there's 6. Okay, and then I'm going to do it down here. So 5 and 7. 6 and 5 first, sorry, then 5 and 7, 4 and 8, so 3 and 9 I've done, 2 and 10, 1 and 11, and then 0. Right, I'm going to mark these 2 points in, and now I'm going to untape my sheet and sketch all these in and sketch the development in, and then show you the final solution. So there's the question done there. So it is Alright, I rubbed that out. I was going to do this development up here, but it would have been too confusing for you. So that's why I moved it down. Alright, cheers, thank you, bye bye.